Welcome to our project, an accelerator for ternary language models based on FPGA for the AMD Open Hardware Contest 2025. Large language models require large memory and high computation capability, which makes them hard to deploy on edge devices. Ternary language models constrains model weights to -101 to reduce model size and enable multiplication-free matrix multiplication. Since linear projection is the second largest computational part in the large language model inference, we focused on accelerating ternary jam, while attention is assumed to run either on CPU, GPU, or other FPGA accelerators. This is the architecture of our accelerator. On the left we have the RepGem model, which manages communication from and to the CPU host. Inside the top level, the data FSM coordinates the data flow. The finite state machine controls reads and writes to VRAM and FPGA HBM, and also drives signals to the processing elements, which performs the actual accumulation and subtraction. Finally, the outputs such as clock cycles and dawn signal are reported back through the RepGem to the host. Our Coyote workflow is illustrated in this figure. The CPU first offloads data from DRAM to the FPGA HBM. It then configures the accelerator by writing to control registers, which are connected to RepGem from previous slide. Through Coyote, the FPGA reads and writes from HBM to provide data for computation. Once computation is completed, the CPU transfers the results back. Let's continue with the demo. We deploy our accelerator on the heterogeneous accelerator compute cluster. By running our accelerator on hardware through Coyote, we get the following output: the matrix sizes and the sparsity, the latency in nanoseconds, and the required clock cycles. Thanks for watching.